Yes, thank you. I'm going to introduce one of my work. I made a portable sort of concurrency library on Scheme. This is how it works, and that's sort of the introduction for that. By the way, this session would be a little bit shorter than the previous one, so if you have questions or whatever, please prepare. It's going to be soon. All of you know, well, recently you don't have single core CPU anymore. You have multiple, double, triple, quadruple, whatever. So you want to use all of the blood from the CPU. The last drip of the blood, you want to use it. So you need to require all the multithreading, etc., etc. And the Scheme has SRFI 18. But SRFI 18 has only the primitive APIs, such as creating a thread, mutex, conditional variable, and those usually causes, well, deadlock, race condition, whatever you want to, well, you don't want to probably. So let's see how it works with the SRFI 18. If you see this, it's going to do just simple tasks, creating 1,000 threads here, make it asynchronous call, and internally just doing this fib. This is Fibonacci, right? It's not a fact, yeah. Then put the result into the somewhere global variable. Before setting, you need to lock it. Pretty simple. But nobody wants to use the global lock. What if you lock outside of the thread? Well, thank you very much. The result values are globally stored. Actually, this will be the same again, but anyway. Creating 1,000 threads wouldn't be efficient, or probably you don't want to get it. This is because some of the architecture has the limitation of number of threads. So I made a library which called UT Concurrent. If you want to see, this is the repository site. This library provides the concurrent data structure and the APIs. Should be portable for both R6 RS Scheme implementation and R7 RS. But unfortunately, not really a lot of SRFI 18, or not only lots of implementations support SRFI 18. So be careful if your implementation support that. Let's say Guile support it. One of the data structure which provided by the that library is a shared queue. This queue provides the atomic operations. So let's say I wanted to make a nicer animation, but I was too lazy to make it. So if the value is into the shared queue, and so this is the one, and this goes in. But simultaneously, if somebody wants to get the value from the queue, then this will be blocked. And again, so if you want to put it, block, and block. And if the value is put it in the queue, then this one will be notified to get one and to get the element. And these are still blocked. Pretty simple. If you use the shared queue with that example, then you can just create the result here. And instead of making the global lock, you just need to put here. So it's getting simpler, reducing the 2 lines. The rest is almost the same, creating a thread. And this is getting the result of the task. This is the result of the thread execution. So the thread execution actually returns true. If something happens, you can also return false, and then you can see this thread failed. Thread pool. Thread pool is the pooling of the thread. Basically, creating a creation of a thread, it might be expensive. Let's say Guile if you create the 1000th thread on Guile, it's going to stop or it's going to abort because of the memory, out of memory error. Even only the platform level, Windows has 2000 threads depending on the condition, but so you don't want to make 1000 or 10,000 threads. So reusing thread would be nice to have. This is the usual thread pool. So usually only one queue, could be the shared queue. Then job is coming in, and one of the available thread takes that job and execute it. But our thread pool is actually a little bit different. All of the thread has own channel for these jobs. So thread pool container checks which queue has least task set, and find the least task and push the job into the queue. And if the thread is available, then this thread takes the job from there. Why? This is the actually reason. The SRFI has the mutex state, and if the mutex was abandoned or the thread which locks the mutex was terminated and without releasing the lock, then it's going to throw the abandoned mutex exception. So to avoid that, each thread has own channel. What I've already told, the thread pool checks the least busy thread. Then if it's fine, then it's going to push it. But if this is the case, then it's going to be just say, hey, the last thread is always empty, but let's say 100 thread, 1 to 99 thread is always busy. Then it's going to iterate every time and 1,000 times the checks. So to avoid this case, the thread tells the pool, I'm available. Then thread pool can check, oh, this thread is available, then I just need to put the job in it. If you use the thread pool, just create one, the same, and push a task into the thread pool, then get the result. Well, since we reuse the thread, we cannot get the execution result. Future and executor, this is inspired by the Java, JSL, I forgot the number, something, 180, I forgot. This is because thread pool cannot retrieve execution result, as I told. Future is a task, basically, but it can retrieve the result of the thread execution. And executor execute the futures. Then after the execution, users can retrieve the result from the futures. So in that case, you need to store future somewhere. If you use the future and executors, instead of creating a thread pool, you need to create a thread pool executor. Well, there are a couple of variety. Well, one executor type. It just other one is a fork and join. It just create a thread and just let it go. But we want to reuse the thread. The rest is almost the same. Executor submit. Push the thread task to the executor. Then it's going to return the futures. So if you want the result, then you need to store it and get the result of Fibonacci. Then here you can get the result of the futures. Oh, I might even spend 5 minutes. Using the library reduces explicit locks. As you saw, mutex lock, mutex unlock was gone. Explicit thread creation, make thread start were gone. Resource management. Thread pool creates only the 100 thread and reuse all the thread. So is the executors. That means less deadlock. The library itself doesn't guarantee the manual lock or whatever. So if you want to lock somewhere, then you can lock and you can cause the deadlock. But unexpected deadlock will be less. Because it manages the resource, it should be better stability. Like if you use this library on the guile, then if you create the proper amount of thread, it wouldn't get the out of memory error. Actually, there was one extra thread, but I didn't mean. So please use it. And if you have any question.
Let's thank the speaker. Another question.
So what's the difference between your implementation and the Gaia live? Gaia has a live named features.
The main difference would be this is portable. So you can use, let's say, Gauche. Chibi scheme you can also use, but I'm not sure which side of the bug, but it's a little bit unstable. And Sagittarius, you can use this library. So if you want to make the portable script, then this might be the option.
Okay, so except for the portability, it's the same idea of that.
Well, the only thing is I'm not familiar with the Gal's future thing. I believe it's going to just create wrap the thread and run the thing. So the thing is, it does have the resource management. Let's say thread pool. Probably Gal doesn't have the thread pool. What does it?
Actually, it does. Yes. It uses a thread pool and the work stealing.
Oh, I didn't know. Okay, then if you are the Gal user, you don't mind the portability, then it might be the Gal's future.
Okay, so the benefit, the good point is the portability, right?
Yes, the portability. If you want to portable something, then it is pretty much important to write a portable library.
Okay, thanks.
Also, I'm just nitpicking, but I think traditionally the future primitives are called future and touch. No? I think you were using future get as primitive name.
Yes. Yes. Somewhere future get yes. Yeah, and it's gonna block if the execution isn't done yet. So might be yes. There are a couple of APIs checks if it's already done or not, but I just didn't put it there. Yes.
Maybe I missed this. Have you implemented anything large scale with this?
Yes, well, it's not large, but I used the thread pool to use the server-side script. And if the server gets the socket accepted, then it's going to push the socket into the one of the thread. Then in the thread, it's going to be used. And the number of things, let's say for the server, it's a dispatcher for the thread. And so if, let's say, 10 threads are in the server, then this 10 thread will get one of the socket, sort of like this design. And also, I'm using the executor in the future as a unit testing. So if I'm also implementing the Sagittarius scheme. So one of the things on the concern was the test time. If I run without using the multi-thread and stuff, it's going to cost a lot of time. And I'm also using it on the hosted CI environment like Travis, but those are time limited. So I want to run the test simultaneously, and I'm using the executor if the test runs properly or not, and what's the result and stuff. So daily used, yes. Yes.
So it sounds like you've implemented your own hybrid threading, and you said you picked a fixed number of kernel threads to use, like 100, you say?
Yes.
So is there a reason why you picked that number? My impression was that can be kind of tricky to pick up.
Yes, choosing the number of threads will be very important. I usually use the, let's say, the double of the CPU number. If the hyperthread is used, then using those numbers. And the 100 is because I put the 1,000 thread creating the 1,000 thread on the example. So if I made the 1,000, it's a little bit silly. So a little bit less. But if it's 10, basically I was also writing this script, and if it's 10, it's going to take a little bit more time than I want to, so I put 100. That was sort of nice number for me to write that example. So no reason, just arbitrary number. Yes.
Does the implementation support mystic futures? Like you have one future that creates another future?
Yes and no. The thing is, then future itself doesn't know where it's actually executed. So, and if that future, and if you want to get the result, then in that future you need to store that future. And it may indeed cause a deadlock, because this future, let's say if the thread pool contains only one thread, and then execution future push that, and wait for this first one. In that future actually waiting for the future which is pushed by this future, then it's going to be deadlock. So it's not really supported. It might be the future task, yes.
If there's no more questions, let's thank the speaker again. Oh, was there another
Sorry,
question?
one more. Did you run any benchmarks?
Yes, I was lazy to create the table. So I was pretty busy with my kids, and then yeah, before I came, I was also busy and stuff. So I was even working before I came Nara. Yes, I came Nara yesterday, but day before yesterday I was even working with slide, and I didn't have time to create the benchmark slide.
We pushed you forward, so sorry about that.
It's okay, sorry.
What kind of performance difference did you see with thread pool versus auto threads?
If you use only the thread, if you don't get any managed, then performance-wise, thread pool was the best performance. I don't remember the percentage, but after 1,000 thread, you can see the difference between other benchmarks. So if you're just creating the thread, it's going to get slower, and let's say Guile wouldn't even handle it. And other implementation, I think the Chibi was the only exception. It couldn't see the difference, or even thread pool was not really better performance.
It's probably because Chibi doesn't use native threads. It has its own interpreter threads.
So it's actually the single thread.
Yes.
I didn't know the detail. So depending on the implementation, you don't get the performance better. Yes.
This is a statement, not a question, but we're still waiting for performant parallel implementation of mini Cannon.
Yes.
You or anyone else wants to take on that challenge? Do you think this library would be useful for implementing something like parallel?
I believe so. well, the honest answer would be, well, I hope so. And I also want feedback. In this case, this performance would be worse, or those things. Because right now, I'm the only one using this library, and the one feedback wouldn't be enough. So if you guys can also use it and then get more feedback, then I can improve it.
Have I missed anyone else who had a question? No. All right.